All right, in this lesson here, what we're going to be doing is taking a look at operators. This is a lesson all about symbols and the magic of symbols and what they can do for you. We need to go ahead and introduce this right now because as Joel starts typing some of his funky, complex-looking code, he's going to be using symbols like crazy, or shall I say, operators like crazy. Now, you've already seen a basic operator, actually a couple operators at that, but let's say the most basic of the ones you've seen so far is the equals, the assignment operator, which is a single equals. And there is a difference between a single equals and a double equals. Trust me on that.
Yes, there is.
So with that, let me go ahead and turn it over to Mr. Joel.
All right. So first thing, let's go ahead and create another temporary variable. Actually, the first that we've created so far, but we can say temp int, and let's initialize it to, say, 5. Okay?
I say 5's a great number.
Looks like it.
It sure is.
So let's jump to the next line. Let's create a second temporary
Ooh,
value.
you're living on the edge.
And we'll just call it temporary integer 2.
Okay.
It's kind of ugly, but it'll work.
How about temp int A and temp int B?
Okay, just to make you happy.
I'm now happy.
All right, Buzz is happy. And now what we can do with this is actually run any kind of expressions or operators we want on these variables.
Okay.
So let's create a final. So final combination. Okay?
Okay.
So I know an interesting name, final cone.
Yeah, total would have been good, but...
Okay, fine. Picky. So now what we can do is...
But that's the beauty of variables. You can name them whatever you want.
Whatever
as long as you adhere
want.
to the couple of guidelines that are in place.
Exactly. So now we have 3 variables. A temp int A, which is equal to 5, a temp int B equal to 4, and a total equal to 0.
And he's been using operators.
Yes, I have. I've been using an operator, the assignment operator.
Which is take whatever's on the right and put it into whatever's on the left.
Right.
Okay.
So let's actually go ahead and type total on the left and use our assignment operator, which is just Buzz just said. What's going to be put in our destination, if you will, is our total, which is on the left.
That's right.
And what we're going to put into our destination is on our right.
That's right.
So let's go ahead and type temp int A, and now we can use any kind of addition, subtraction, division, multiplication, anything we want right now. I'll just go ahead and use an addition.
Okay.
And we can
Which is an operator.
It is an operator. And we can say temp int A plus temp int B.
And terminate. There we go.
So,
as I steal the mouse, basically all we're doing is we're saying take whatever is being stored in this variable, this memory location, which in this particular case, remember, it's storing the value 5, and add to that whatever is being stored in this memory location, which is the value 4. And if you take these two guys and you add them together, you do end up with the incredible number
of 9.
And 9 is what is being stored in total. Remember, we did initialize it with a 0. That 0 is being replaced by 9. We're not combining it or whatever. We're just putting 9 in there, period.
Right. So now, let's go ahead and print this out so that you can see that we indeed do have something working here.
Just in case Buzz was making all that up.
Hey, it's possible. So we can say temp int A plus temp int B equals, so this is just in our quotations, this has nothing to do with reality.
Meaning that'll print out for real.
Right. And we can go ahead and say total with an end line. So it's going to print out total temp A plus temp B equals total. And if we press Control F5, yes, we do want to build, you'll get temp int A plus temp int B equals the magic number 9.
Hooray!
So with that, it's kind of
But
now...
to make our C out and make a little bit more sense, as opposed to saying temp int A plus temp int B, how about we replace temp int A with what's really being stored in that variable, and then print out the plus as a string value?
We can even do that. So that would mean we could put in here temp outside of quotation marks.
Or how about just do something like this? We just simply take that out there, and then we come put in, there we go, look at that. Drives Joel crazy when I steal the keyboard like that. I'm not a good student.
No, you're not.
I'm sorry.
So we have C out here, and we say temp int A. So this is a variable. It's actually going to take the value 5 and replace it.
Right.
And print that out. And then we're going to add, which is in quotation marks. And then we're going to print out B. And now we're going to also need another output here that's going to say equals. So
and
like
he's just putting the spaces in there. You'll notice over here with our plus and with this, just so that the numbers and the symbols aren't butted all up together.
Right.
That's all.
So let's go ahead and press Control F5. Yes, I want to build. And you'll notice 5 plus 4 equals 9.
Isn't that nice?
It's beautiful.
Okay.
So we can press any key to continue. And let's try something else. We can also go in here and say total. And we can say equals. And we can go ahead and say temp int A minus temp int B. So using another operator, the minus.
And the cool thing about this example, actually I say, tink, tink, keep those two in, because what's going to happen, this is really going to drive home the point that I had a second ago, and that is we've already got a number being stored in here, but by coming down here and doing another assignment operation like this right here, this number that was currently being stored in here is about to be replaced with a whole different number, not combined with or anything. Replaced, that's all. And another thing to point out that wasn't really mentioned a second ago is we know that there's an assignment operation of whatever's on the right goes into whatever's on the left because of the assignment operator. But here's something else to keep in mind. The expression on the right-hand side needs to be finished first. So we've got this subtraction over here taking place, or we've got the addition that's taking place. All of this is evaluated to a final number first and then dumped over into the other side.
Right.
Okay.
So if we look at here, we have our, let's just, for safety's sake, let's change this into minus. Actually, not for safety's sake, just because it looks better.
Just because it looks proper?
So we can press Control F5, and if we run this, you'll notice 5 minus 4 equals 1.
Hey, that's amazing.
Yes, it is.
Our computer's smart.
Yes, it is. It's kind of scary.
Yeah.
So we can press any key and kind of drive this home even a little bit better. Let's go ahead and set a breakpoint.
Ooh.
And press F5. And now we're inside of debugging mode, so we can debug our code. And you'll notice temp int B equals 4, temp int A equals 5. And now we're at this line where we're going to assign total with the addition of temp A plus temp B.
And you'll notice down below the total currently is 0. That's right.
So if we press F10 to execute this line here, so we press F10, now it's actually run it, and you'll
take note where your yellow arrow is.
And the yellow arrow is here, so that means we're now on this line. We haven't executed it yet.
That's right.
Our name is total, and look, it's changed to 9. Actually, let's click away so you can see it better. Our value is now 9.
And it just changed colors, too.
Yes, it did. So if we press F10 again to run this next line, which is going to take A minus B, run that, and look at that. Total equals 1.
Amazing.
So very, very cool. So let's stop debugging here for a sec, and let's go into here and show you some other stuff. Why don't we go ahead, there's also divide and multiply, which is kind of interesting.
Okay.
However, you will see a small problem here. What is 5 divided by 4?
5 divided by 4, so that's
2.
going to be 1 point something that's being stored in total, which happens to be an integer composed of only 4 bytes. Oh, I'm sorry. I'll get back to reality. Okay.
Which will give us a 1.
We're going to be truncating stuff.
We'll be truncating, which is a bad thing.
Yes.
So what we need to do is go ahead and go in here and change these to floats. Okay? So now we're going to have a greater deal of accuracy.
That's right.
So if we let's go ahead and comment this one out just for now. And let's press Control F5. Yes, we want to build.
And since he left the minus in there, it's going to look like 5 minus 4 equals 1.25.
Good point.
It's all good,
let's go into here, change this to divide to make Buzz happy.
Just to make sense.
Yes. And look, we do have 5 divided by 4 equals 1.25.
Hey!
Look at that. So now everything is good. Now we actually have our decimal point values on the right.
Yes.
Which is nice.
Absolutely.
So if we delete this, actually comment this one out, and now we do a multiply. And let's go down to our cout here and change this divide to a multiply just so it makes sense. Press Control F5. Yes, we do want to build, and you'll see 5 times 4 equals 20. Of course, in this case, we could have just left this as an integer, couldn't we have?
That's right.
But it's just what I happen to be doing. So, I mean, if we did go in here and change this to 5.5 or 5.4 and change the temp B to 4.3, and we ran this, you'll notice that we took 5.4 and multiplied it by 4.3, and we do get a nice round number.
That's right.
A nice correct number, actually. So let's press any key to continue. Now, aside from these very simple operators, we do have a lot of other operators as well.
Some cool ones. Oh, sorry.
Yes, we do. So, for instance, we could go in here, and we can say, let's go back and change this to, say, 8, and let's change this to 2. So, let's go into here, and let's leave that at that.
I know where you're going with this.
And let's print in
a modulus.
Yes,
we
did.
No, so we're checking for
the remainder of
that's right.
temp A divided by temp B.
That's right.
So if we run this, you might notice we have a little problem.
Mm-hmm.
Do you know why? The reason is because the left operand has type float. When we're dealing with modulus, you can only find the remainder with our modulus operator if they're integers. So we can go in here and change this to an int. Let's change all of them to int. And if we run this again, Control F7, you'll notice that it compiles perfectly fine.
That's pretty special, Joe.
Yes, it is. So if we press Control F5, and yes, we want to build it, you'll notice that 8 modulus 2 equals 0. Because 8 is divisible by 2.
Right. Stop saying what I'm saying.
So, that's pretty scary.
Yeah, it was.
So let's go in here. We also have, say, and, or,
well, real quick, back to the modulus thing. People may be wondering, why would you want to do something like that? It's a great way if you want to like do every other something,
right.
Or
if we go use a loop or something and loop through every other index in an array, for instance. All that can be possible with our modulus.
Exactly.
So what we can do here is let's try something else. What if we said temp int a? This is going to be kind of scary.
Ooh.
Equals temp int b. Now,
Ooh.
what is that?
Ooh, that's 2 equals. That's like an equality type statement.
Yes, it is. So what it's checking is it's going to say, is temp a equal to temp int b.
So this is not an assignment out there, ladies and gentlemen.
This is not an assignment.
This is not going to take whatever is in temp int b and put it into temp int a.
No, it is not.
Okay.
And another thing that you may want to see here is that I put this in parentheses just so it makes sure that it runs whatever's in the parentheses first.
Right.
So if we run this, is temp a equal to temp int b?
Right.
Is it?
Probably not on planet Earth.
No. So
well, you got 8 and 2. But now, Friday nights they're equal. Just kidding. Go ahead.
So if we press Control F7, you'll notice that it's perfectly happy with
Absolutely.
that. So let's say temp int a, and we'll change this to equals temp int b.
Right.
And if we press Control F5, you'll notice that temp 8 equals 2 equals 0. In other words,
they're
8
not.
equals 0 is not true.
Right. Now make them equal to one another and check out what you get.
Yeah. So if we go in here and change the temp int b to 8, and
always got to pick on the little guy.
I know. If we press Control F5, yes, we want to build. We go in here, 8 equals 8 is a true statement.
Right, giving you a value of 1,
right.
Which is true.
So if we press any key to continue, we also have a bunch of other operators. We can say not equal to.
Oh, yeah.
So temp int a is not equal to temp int b. Is that a true or false statement?
Well, right now they're equal to one another.
So that means it's a false statement.
That's right.
So we should have in our total a value of 0.
That's right.
So if we press Control F5 and look at this again, you'll notice 8. Oh, well, keep forgetting to change this.
I wasn't going to say nothing.
Sure.
I was just going to smile at you. I've already reminded you once. How many times do you need?
So we have 8 does not equal 8 is
that's
false.
Right.
So that's very good. Of course, if we change
this,
it would be
so if we said 8
true.
to 2 again, they would not be equal, and that is correct. It's a true
right.
statement. So you'd get a 1.
Right. So there's all sorts of other operations we can connect with this. For instance, let's say we also have, well, let's go ahead and introduce these as well. Temp int a is greater than temp int b.
Mm-hmm.
So we can say 8 is greater than 2. Mm-hmm. Well, is 8 greater than 2?
Last time I checked, yes.
So that would give us a value of 1. Let's go ahead and copy this so we don't have to do this quite so many times. And let's just comment this out. If I didn't make this clear before, commenting it out, that means that it's not going to be run at all. It's completely disregarded.
Those are just simple notes being left behind for the programmer or for anybody that may come back in later reading the code. And trust me, comments are important because you may work all Friday night on something that's got some cool logic to it and then have to put your code up for a while, come back to it 3 days later, and if you didn't comment anything and the logic gets nice and deep, you may look at it and go, what the heck was I doing?
Yes,
and then you end up spending an entire day trying to figure out the logic behind what you were setting up earlier.
Right.
So comments are really good. And in this case here, Joel's been using them to just quickly simulate removing lines without physically removing the line.
So what we can do here is say, let's say total temp int a is less than temp int b. Now that is a false statement.
Mm-hmm.
So let's go in here. Let's put a breakpoint down. Excuse me. And let's press F5. And let's link this together. And now we're on this line. If we press F10, you'll notice that temp int a is greater than temp int b because our total that we have here is now equal to 1.
That's right, so it's true.
So if we run this next line, which says temp int a is less than temp int b, we run that. That is a false statement because our total is now equal to 0.
That's correct. Notice our next line of execution, by the way, is not on the comment line as well.
Right, it skipped right through it.
Look where the yellow arrow is.
Right here.
That's right.
So let's stop debugging. Now there's still a few more things that I just want to kind of demonstrate, and that is the ampersands, double ampersands, and
the double pipe symbols.
The double pipe symbols.
Okay.
So let's go into here and let's say, well, another thing. We can also go in here, up till now we've always been using variables.
Right.
We can also use constants.
Absolutely.
We do not have to use variables all the time. So if we delete this line, and let's go in here, and we can say total equals 5 as we did before.
And that's going to put 5 into the memory address.
Yes, it is.
The total's representing.
And like we did before, we can say 5 plus 4. That's a perfectly cool statement.
That is. It's going to put 9 over there now.
Right. If we put, it's going to put 9 in total. Exactly.
That's right.
So that's going to work. That means we can also do this. 5 is greater than 4. So that means the total should give us a value of 1, which is true. Now we can introduce the ands, or double ampersands, and the double pipes.
Okay.
If we say and, let's do another parentheses, which means we want to run this as fast as possible, basically, from left to right. We can go in here and say, is 3 greater than 4? Or, let's say 3 greater than 2. Let's make it true. So both of these statements are going to be true, correct?
Okay, that's right.
So this one is going to be true, and this one's going to be true. So
and if both are true, since we're using an and, the final value will be true.
Right. This bitwise and operation is going to return 1.
That's right.
So if we put this all in parentheses...
That's so cute. You use bitwise. You're like really getting professional. I love it.
So we have this whole thing put in parentheses. That means it should run and then give us back the value to total. But before we actually run this, let's do another line. And let's make this first one false. So is 2 greater than 4? No.
No.
So this one's going to equal 0, and the one on the right is going to equal 1.
And because it's an and, they both have to be true to result in a true coming back. So this will give us a 0.
So this first statement, let's say, now this is a good example of using comments, we're going to say total will now equal 1.
Okay.
If we go to here, total will now equal 0.
Sounds good.
So if we go ahead and run this, let's probably push F5. Yes, we want to build. And now we're down here, total equals 0. If we press F10, you'll notice that total is equal to 1 because both of these are true.
That's right.
If we run the second one, you'll notice that the first one is false, the second one is true. Therefore, if you AND them together, you're going to get a false statement.
You got it.
So if we stop debugging for just a sec, we also have the OR operation. So if we put in a double pipe here, then what's going to happen is it's going to say, if this one is true or this one is true,
give us a true
value. So the first one here is equal to 0, second one equals 1, therefore it's
one
true.
Of them is true. So we're going to get a true.
Right. So let's go ahead and debug this again just to make this clear. And if we press F10, you'll notice that it is equal to 1 as it was before. If we execute the second one, it still equals 1.
That's right. Now, these logical operators become very, very important later on as you start to, develop some logic.
Exactly. So, one final thing before this lesson comes to a close, sad. We can go in here, and let's actually delete these 2 lines. You get the idea. And we can say total equals 5, okay? Now what we can do is say total plus equals 3.
Ooh,
Isn't that fancy?
He's pulling out the big guns.
Yes, I am.
This is for the truly lazy programmer.
That would be me.
Actually, I use this stuff like crazy.
So now total is 5 up to this line. If we get down to this line, total plus equals 3 basically can be replaced with, let's just go down here, this can be replaced with total equals total plus 3. So these 2 lines, this one and this one, line 14 and 15, are identical. They're doing exactly the same thing.
That's right.
So
and let me point this out too, because I've seen some beginners in the past get a little bit confused with this. Even though we're going to be updating what's in total, everything that's on the right is evaluated first. So whatever is currently in total, which is 5, if we just ignore this guy right here. So in other words, going from this line up here, then we'll skip and come down to here. So 5 plus 3, that gives us 8. Then 8 is finally stored over in here.
Right.
I only say that because I've seen some beginners in the past get confused with, well, I'm updating this, but I'm using what I'm updating here.
Right.
And it's not a bad thing.
So let's go ahead and run this just to make sure, just to prove that it is working indeed. So let's lay down a key. Yes, we want to build. And now let's go into here. Total equals 0. Run this. Total
5.
now equals 5. Run this statement.
8.
Total now equals 8. So
Excellent.
Everything's working really, really good. The same thing applies for multiply, minus, and divide. So we can say minus equals, divide equals, or even multiply equals.
You got it.
All works fine. Now, and just to make double sure, we can also go in here and type in a variable, say temp int a, and it's fine. Just to make sure that you realize that no matter where you can put constants, you can also put a variable.
That's right.
And one last thing, I said one last thing already, but this is truly the last thing. If we say total equals, we can say minus minus temp int a. So what does that mean, Buzz?
Now he's getting into the good stuff.
Right.
Well, this is where we're going to take 1 away from temp int a and put that over into total.
Right. So.
Well, often, let me say this, often people find themselves in situations where they're having to write a counter or some sort of code that's got a variable that's incrementing by 1 each time.
Right.
And as opposed to having to write something like total equals total plus 1, which of course you could just say plus equals and 1.
Right.
What they did is they kind of simplified things by just like going total plus plus or,
right.
You know what I'm saying.
Yeah. So if we go into here, and let's go ahead and run this, because this can be a little bit confusing. This is the pre-increment.
That's right.
So if we run this, total equals 5. Now, in temp A, you'll notice that we have 8. So if we run this, what it's going to do is first minus temp int A by 1, and then put that into total. So if we look at this, you'll notice that total now equals 7,
That's
which
right.
is equal to temp int A minus 1.
That's right.
But you'll also notice that it didn't just change total. It also changed temp int A. So it changed both of those values, but before it assigned it, that's why this is called the pre-increment, before it actually initialized total to that value, it decremented it 1.
Right.
So the same can be applied for, say, addition as
well. You know what? Before you go further, rewrite that line so that they could see what that line looks like. In other words, you could say that total equals, and then you'd want to do temp int a.
Basically, what we could do is say temp int a minus minus.
Yes.
And then we could go into here and say total equals temp int a.
You could. I'm wanting to get the number 1 in there somehow so they can actually see it there.
So we could say temp int a minus 1.
Right. So that's what they're.
The only difference here is that temp int a is not actually changed.
Exactly. That's very important to get across.
Right.
In this case right here, it's developing a new number that can get stored over here.
Right. It's not actually changing
altering
temp int
this.
a.
By putting that minus minus, that's why a second ago when I was talking about the plus plus as example with talking about doing a counter, I used total to refer to that because total was being changed. What Joel did is he snuck a good one in on you guys. By coming over here and putting the minus minus, mixing that in with temp int a, we are affecting this and affecting this.
Right.
Okay.
So to make this maybe double clear, we could go in here and say total plus plus.
That's a good way to always start explaining this one.
So if we say total plus plus, what that's going to mean is we have total equals 5. We come down to this line, total plus plus, and that's going to actually increment our total by 1.
Right.
Which could be rewritten on line 14 here, plus equals 1.
Right.
Or, just to give another example, total plus 1.
That's right.
All the same thing. So
now, he did mention something lightly just a second ago, and that is the pre-increment or the post-increment.
Right.
Or decrement.
Very, very important.
Very important. Is there a way you can perhaps mix that in with the cout type stuff?
Sure. If we go into here, let's actually delete this, and let's create a new cout statement. We can leave that commented out. We can say, let's say, temp int a plus plus. So if we say, well, let's make this a little bit easier. Let's put in a little quotation here. Let's say temp int a equals, and then end that, print that out, and say end L.
Okay.
So what that's going to do is come into here and say temp int a, which now, if you remember up here, is equal to 8.
Right.
And if we come down in here, it's going to say, well, temp int a plus plus.
Right, but the plus plus in this case is a post operation, which means it's going to
actually happen afterwards.
That's right. After the cout takes place.
Right. So let's just delete this total equals 5 just to make things a little bit more clear. If we go into here, press Control F5. Yes, we want to build. Go into here. You'll notice that temp int a equals
Interesting. It
8.
looks like it didn't change at all.
It didn't change at all. However, if we go into here and let's print this line again, but without the plus plus,
we'll see that it has indeed changed.
Right. So if we go into here, press Control F5. Yes, we want to build. Notice that temp int a has indeed changed after this first line. It just didn't print out that value.
That's right, because, again, this is a post-increment. We had the 2 pluses at the end, and because of that, then this entire line executes without affecting the contents of temp int a at all.
Right.
If we were to take these 2 addition symbols over here and put them over here on the left-hand side so that we're doing a pre-increment, then what would happen is it would first increment the contents of this before executing cout, and in this case, we would see that the cout is equal to 9, or the temp int a is 9, and temp int a, well, it's still 9.
Right.
So go ahead and
we can actually do that. If we go into here and say pre-increment and delete these 2 out, press Control F5. Yes, we want to build, and you'll notice that now both equals 9 because it pre-incremented.
That's right.
Exactly.
In other words, it executed that before executing the line.
Right. So actually, I think with that pretty much does everything.
Wraps up everything we want to talk about in regards to operators. All right, so thanks a lot, everyone.